Alright guys, here's a video to help you with function operation and composition. This is for worksheet 10. I'm doing quite a few problems from your worksheet 10 to help you out. Okay, so here's the first one. It's for problems 11, 12, 13, and 14. So they gave us two functions. Let me zoom in a little bit more. Try to make it a little bit more clear here. My printer wasn't working really well, so I didn't print this really nice, but here is, you should have the same questions in your worksheet. So let f of x be 2x minus 4. So this is one of our functions, is the f of x function. And then it says, if there's a typo here, it should say, and g of x is negative x squared. So let me write it bigger here, and g of x is negative x squared. Okay, so that's all they're saying, and g of x is negative x squared. Perform the following functions operations. Okay, so first they're asking us to add them. Okay, remember when I gave you the notes in class, I said sometimes they'll ask simply this way. There is another way to show this. It's called f plus g of x. Either way, it's two notations saying the same thing, asking the same thing. Okay, so I'm asking you to grab the function f and add the function g as well together. So I'm going to grab the function x, which is 2x minus 4, plus I'm going to add the function g, which is negative x squared. Okay, maybe I want to put in parentheses so it doesn't look so ugly. I'm not multiplying, I'm just combining like terms. Since I'm combining like terms, there's nothing to combine with the negative x squared. So in functions, we always try to write the highest exponent comes first. So negative x squared. There's nothing for me to combine with x squared because there are no others x squareds. And then my positive 2x, and then my negative 4. So my f of x plus g of x gives me a brand new function, which is right here. Okay? Now it's asking me to multiply f of x times g of x. Another notation for this would be f times g of x. That's another notation. It's asking exactly the same thing. I want you to be familiar with both notation. So all I'm doing is I'm going to grab f of x, which is 2x minus 4. I'm going to put in parentheses, and then I'm going to multiply times g of x, which is negative x squared. Okay? I told you in my notes that most of the time you're going to do some sort of a little foiling. First terms times the first term and so forth. So I'm going to do 2x times the negative x squared. I'm going to get negative 2x, x times x squared is x cubed. Okay? And then I'm going to do the negative 4 times the negative x squared. I'm going to get a positive 4x squared. So there we go. There's my multiplication of the function f of x times the function g of x. Okay. All right, now let's do a composition. Okay, they made it nice for us here. Another way of representing this composition would have been g of f of x. This too means exactly the same thing. You may see it this way, or you may see it already nice and more explanatory for us this way. Okay, so all I'm doing here is I'm grabbing the function f and I'm putting inside of the function g. Let's do it slowly. Let's first write the function g. The function g of x is negative x squared. Okay, so whatever I replace inside of here, it replaces my x. If I wanted g of 2, okay, number 2, then I would have negative 2 squared. So as you can see, x is my domain. Whatever I input in here gets input for x. Okay? But I don't want a 2. What I actually wanted is g of f of x. So I'm going to have negative, I'm going to have a space, and I'm going to have my squared, because whatever I am replacing here, I am also replacing in here. And I want the function f. I know what the function f of x is. The function f of x is 2x minus 4. And there you go. That is the composition. I put the function f of x inside of the function g of x. If you need to clean up a little further, you can. I am actually satisfied with this answer right here. You made a composition of f of x inside of the function g of x. Now this one, number 14, is just a subtraction. I'm asking you to write f of x first. I always told you order matters. Okay, order matters here. Please always remember order matters. All right, I want f of x first, so I'm going to do 2x minus 4 minus, because I'm dealing with subtraction, I'm going to be very careful and I'm going to open a parenthesis for my next function, which is the function g of x. My function g of x is just negative x squared. Okay? Anytime I'm dealing with subtraction, I try to be very careful. So I have 2x minus 4, and a negative times a negative is plus an x squared. It's nice, but it's not in the nicest written form. We always like to get the highest exponent and put it first, so we can write it in decreasing exponent. So x squared comes first, and it's positive x squared plus 2x minus a 4. And there you go, you got a brand new function when you subtracted the g of x from the f of x. Okay? So hopefully this helps you a little bit. Let's do another problem. And that would be number 17. I went to the last two questions because I know they are the most difficult questions. It says, let f of x be x squared, and let g of x be x plus 1. Okay, so I have two separate functions here. They want me to do a composition. I know that because I see this little O, f of g of a. Okay, so this is saying f of g of a. That's what it reads, okay? So I want to plug in a into my g function, and then when I'm done, I need to plug that in into my f function. Another way of writing this, I'm going to rewrite it right here, is saying I want f of, now I want g of a, okay? So that's why you need to be familiar with both ways. Now that I know that what I want to do is inside first, I'm going to take care of g of a maybe separately here on the side so I don't get confused, okay? I know that g of x is x plus 1, but I need to find out g of a. So g of a, instead of an x, I'm writing an a plus 1. That's what g of a is. Now I know that g of a is a plus 1, I can come and plug it in and replace it right here. So f of g of a is the same as f of, instead of g of a, I know what g of a is a plus 1. So I'm doing a plus 1, okay? So now I want f of a plus 1. So now in my f function, I am going to plug in a plus 1. My f function is just something squared, okay? That's what my f function is. F of x is x squared. So I want f of a plus 1, therefore I'm going to put a plus 1 in here. So to write it all together, f of g of a is just a plus 1 squared. And that would be our final answer. We are not solving anything, we are composing things, okay? So as you can see here, if I recap slowly, I want g inside of f, okay, the second function inside of the first function. So I put the g of a inside of f, but first I need to find out what is g of a. Then go ahead and plug in a in the g function, so I get a plus 1. Now I know that g of a is a plus 1. I come back and I can replace g of a with a plus 1. F of a plus 1, we plug in a plus 1 into the f function, which is a plus 1 squared. Some people like to go further. If they want to expand this further, they can. I'm not sure if you need it. I am very satisfied if you can get to this point right here, okay? So that is your question number 17. One more question is number 18, which is the last one, and is definitely a little bit tougher, okay? So let f of x be 2x squared. Let's play with f of x just for a little bit here on the side, okay? So f of x is 2x squared. If I wanted f of 1, then I'm replacing the x with a 1. I would do 2 times 1 squared. Okay? If I want f of a, then I would do 2 times a and square it. As you can see, I had an x here, then I have an x here. I want a 1, then I replace the x with a 1. I want an a, then I replace the x with an a. And then that's why you keep replacing. It depends what you want to input in your f function. Okay, let's go back to what is asking. It's saying I want f of g of a minus 1. So first I need to do a minus 1 inside of my g function, and then when I know what that is, I will go ahead and plug in inside of my f function. So this is the same as f of g of a minus 1. That's what we really are asking. So put a minus 1 inside of the g function first, and then we'll come over here and finish it off. Okay? So let's go ahead and play with our g function right here on the side. Okay? So g of x is 3 times, I'm going to put a little parenthesis for x plus 1. Because I know that every time I replace something in here, that's what I'll be replacing right here. We actually want g of a minus 1. So I'm going to replace the little spot here that had x with an a minus 1. So 3, I'm going to open a little parenthesis so I can put my a minus 1, and then my plus 1 is in the back as part of the function. And then of course we need to do some little cleanup. It's just some minor algebra work here. So 3 times a is 3a. 3 times negative 1 is negative 3, but I still have that plus 1 in the back. So a little bit more cleaning up, we get 3a, negative 3 plus 1 is negative 2. So there you go. G of a minus 1, g of a minus 1 actually equals 3a minus 2. I found out what that is. Now I can go ahead and insert that into my f function. So let's go over here and replace what g of a minus 1 is. We know that g of a minus 1 is f of 3a minus 2. That's what I'm going to be putting inside of my f function now. Okay? As you can see, my f function is f of whatever I want, and all I have to do is 2 times whatever I want squared. That's pretty much it. Okay? If I want an x, then I would have an x. If I wanted an a, then I would have an a. In this moment, I want 3a plus 2. So I'm going to put 3a minus 2, and then 3a minus 2. Now, just to keep it clean and all nice and organized, I would say f of g of a minus 1 equals 2 times 3a minus 2 squared. Okay, that would be my final answer. I'm just showing you all connected, all this pieces connected. This would be your final answer. Okay, I plug in the a minus 1 inside of g. When I found what that was, I went and plugged inside of the f, and this is my final function. You don't need to go further. A lot of the students ask me, do I need to expand it and multiply it? You don't. This is good enough for me. We're just testing to see if you understand how to compose one function inside of the other. And this is perfect for me. Okay? All right? Good luck. Please come and ask me for more questions. I don't mind helping you, but this should help you with some of the composition. Okay? Good luck. Bye.